So this is an explanation of redox reactions, electrochemical cells, and electrical current. So the reducing agent is going to have a higher potential energy. And then we have the oxidizing agent, which is going to have a lower potential energy. What's going to happen is basically the solution here, the oxidizing agent, is going to bond with the electrons that are going to come down into the cathode. And this movement of electrons right here is called electrical current, which is the organized movement of electrons. And so that's basically what's happening here, is these electrons are moving through here, they're creating like a little light bulb or whatever, and then they're coming down here and they're going to bond with the oxidizing agent, which is like the solution, like all around here.
Hey, I'm the chief engineer of this project, and this is our battery. As previously stated by the chief engineer, we have a simple redox reaction occurring here between copper sulfate and aluminum solid. Now, aluminum solid has no charge, it's a metal. Copper sulfate also doesn't have a charge, but alone, copper ion has a charge of 2+. This is our electrochemical cell. On the right, we have our anode, aluminum solid. During the reaction process, aluminum solid loses electrons and is therefore oxidized. The anode is the site of oxidation. On the left, we have our cathode, the site of reduction. Copper sulfate is being reduced. It's gaining electrons during this process. As this process occurs, aluminum loses 3 electrons and turns into aluminum 3+. The aluminum 3+ ions are transferred to the water, where they move freely. However, they have a positive charge, and therefore 3 Cl- ions come over and bond to the Al3+ to form a stable and neutral compound. On this side, the same is also true. When copper ion is being reduced, it is gaining electrons, copper metal is formed. Copper metal forms onto the cathode, leaving sulfate, a negatively charged ion, by itself in the solution. The sulfate then bonds with the salt. Not the salt, the sodium. The sodium bonds with the sulfate to form a neutral compound. So we have 3 main components of this battery. Our anode, the site of oxidation, our cathode, the site of reduction, and in the center here is our salt bridge. The salt bridge is there solely for the purpose of reacting with the newly formed ions that occur as a result of the chemical reaction.
Alright, so this is the balanced chemical equation. So we're going to have our 2 different metals. We're going to have aluminum and copper. So we start off with aluminum, that's solid, and then copper, 2+, that's aqueous, and that is going to make aluminum 3+, which is aqueous, and copper metal. And so now we have to balance this equation, and so we're going to put 3 there, 2 there, 2 there, 3 there. So this is the balanced chemical equation. Here are the 2 half reactions. So we have aluminum, solid, which is going to be aluminum, 3+, aqueous, and plus the electrons. Then we have copper ion, Q, is going to be
+2 electrons.
Plus 2 electrons is going to be copper.
Hey, we're back. So, just wanted to talk a little bit about the pros and cons of this battery. So some specs about it. We got our voltage here. The voltage of the battery and the requirement was 10.0 volts. We had 2.0 volts produced per cell within the battery. Therefore, to fulfill this, we had 5 cells within the entire battery. So that's perfect, really.
And our cost was actually pretty cheap. It only cost $52.67 to make this battery. And reason being is that aluminum and copper are two pretty cheap materials. And so it's going to be a relatively cheap battery.
Now, you might want to check our work for this because we found some sketchy resources for our copper and aluminum. But
we were supposed to find the cheapest way.
Yeah, Alibaba.com, they gave us some pretty low prices. We snatched them right up. So weight, it's very heavy, but that wasn't a factor in our decision process, Mr. CEO, because it wasn't a constraint.
I mean, it's also pretty big, but we figure you can deal with that. So
let's just run through the pros again. We got it's cheap materials, cheap battery. It's environmentally friendly because these materials do not produce a hazardous waste or other hazardous materials when they react.
And it's also safe because we are going to enclose it in plastic, and that won't degrade with the materials inside the battery, and so there will be no risk of leakage or fire or anything else that could potentially harm you.
And it's a basic battery, meaning that it's rechargeable. You apply electricity, which will come from the solar panels, and bam, it's recharged, and you just use it again and again.
And if you don't have solar panels,
no, but we do have solar panels.
Yeah, but I don't know. If you didn't, that might be an issue. But it's okay. Well, you'll die if you.
Hey, I'm the chief engineer of this project.